Okay, we're going to be going over the Chapter 10 practice quiz and see how you did. All right, so it says for numbers 1 and 2, find the surface area and volume for the following figures. So we'll start with surface area. So the surface area of a prism is the perimeter of the base times the height plus 2 times the area of the base. So in a prism, the bases are always congruent. So this is a base and this is a base. Doesn't matter what's up or down, so to speak. It matters what are the two congruent pieces. Those are the bases. So we got a right triangle here. So the area of the base is going to be 1/2 of 5 times 12, which is 30. And the perimeter of the base is, you can use the Pythagorean theorem here, 5 squared plus 12 squared. It's going to give you 169, and the square root of that's 13. So it's a Pythagorean triple if you happen to know it. So this, my base perimeter will be 5 plus 12 plus 13. So 12 and 13 is 25, and 5 is 30. Perimeter of the base is 30. And the height is, notice this is 20 inches. Okay, it's all in inches. All right. So height is 20. So just plug into the formula. So perimeter of the base, 30. Height is 20 plus 2 times area of the base. Is your surface area. So 30 times 20 is 600 plus 60 is 660 square inches. Then for the volume is area of the base times height. We already found the area of the base here as 30. We already know the height is 20. So 30 times 20, 600 inches cubed. Okay. Number 2, a right cylinder with a circumference of 2 pi inches. So we'll draw our cylinder here. So we're told circumference is 2 pi and has a height of 1.5. So it's here. And we need to find surface area and volume. So the surface area for a cylinder, again, it's the perimeter of the base times the height plus 2 times the area of the base. So in a cylinder, that's the perimeter of the base is pi times 2r. So you got pi 2rh plus 2 pi r squared. So area of the base is pi r squared. So we need to know the radius. So we know circumference is 2 pi. We know that the circumference formula is equal to pi times 2r. So you compare these and you see, okay, if we set these, we know the circumference is 2 pi. We know the formula is pi times 2r. So we can set them equal. So the pi's will cancel on both sides, as will the 2's. And you're not left with 0 over here, we're left with 1. Because divide both sides by pi, and then divide both sides by 2, you get 1. So 1 is the radius. So you put 1 into here, pi times 2 times 1, times the height, which is 1.5, plus 2 pi 1 squared. So 2 times 1 is 2, times 1.5 is 3, so you get 3 pi plus 2 pi is 5 pi. And that's your surface area. So surface area is 5 pi inches squared. Just double checking in my head, make sure I did it correctly. Yeah. Okay. And then the volume is area of the base times the height. So we know the area of the base is just pi times 1 squared, which is pi. So the area of the base is pi and the height's 1.5. So volume is 1.5 pi inches cubed. And you can round those to the nearest hundredth if you want. All right, refrigerated biscuit dough cones. So our dough comes in a cylindrical can, diameter 2.5, height of 8. So it's kind of a narrow deal. Draw a rough picture. Diameter 2. The bases, sorry, 2.5. The bases are aluminum and the lateral face is cardboard. How many square inches of aluminum are used? So that's just the bases. So if you have a diameter of 2.5, your radius is 1.25. So we're looking at pi 1.25 squared, and then we have 2 of these. So and so we're looking at 9.82 inches square. Then how many square inches of cardboard? So that's the lateral area. And so there you're looking at, to find the lateral area, you take the perimeter of the base times the height. So the perimeter of the base is going to be 2.5 pi, right? The diameter is 2.5 times pi. And then multiply that by the height, which is 8. So you could do 20 pi if you want, or you can do 62.83. This is inches square as well. Make sure you're paying attention to units. Okay, next, find the surface area of a regular triangle pyramid. Slant height is 13, base edge is 10, altitude of the base is 5 times the square root of 3. And it says it's a regular triangle pyramid, which means that the base is a regular polygon, in this case an equilateral triangle. So we're looking for surface area. The surface area of a pyramid is 1/2 slant height perimeter of the base plus area of the base. So they gave us a slant height of 13. The perimeter of the base is 30. All 3 sides are 10. And then the area of the base is 1/2 times 10 times 5 times the square root of 3. And that will give us the surface area. So 0.5 times 13 times 30 plus 0.5 times 10 times 5 times square root of 3. Oops. Sorry. So 238.3. And this is in doesn't give me a units, so units square. Oh, I do say at the top, answer in exact values. So, which would mean like, so you'd want 20 pi here. I should have read my own directions, huh? And then for this one, you would do 3.125 pi inches squared. And then this one, instead of having 238.3, you would get so you do a half times 13 times 30, 195 plus, and then this would be 25 times the square root of 3. But that's kind of messy, so either way. All right, backside. Paper covers for ice cream cones are made of heavy paper. Cone A has radius of, let's draw our cones here. So here's my cone A. Has a radius of 1. Oh, we don't have ice cream on top, sorry. So you just got your cone and it has a radius of 1. So 1. And then a slant height of 4. Cone B. Cone B has a radius of 1.25 and a slant height of 3.5. Which cone contains more paper? So this is surface area of a cone, but obviously you don't put paper over the opening where you put the ice cream. At least that's not how I would want my cone. So there's no base here. So it's just going to be 1/2 the slant height times the perimeter of the base. So we're looking at lateral area here of the cones. For cone A, it's 1/2 times 4 times pi times 2 times 1, right? Circumference of a cone is pi times 2r. Then over here, 1/2 times 3.5 times pi times 2 times 1.25. So here we get 2, half of 4 is 2 times 2 is 4. So this is 4 pi. And then over here, 2 times 1.25 is 2.5. It's kind of messy. So 2.5 times, stupid thing. Oh. All right, 2.5 times 1/2 times 3.5. 4.375 pi. So this cone, which has a shorter slant height but bigger radius, has a larger lateral area. So cone B. Find the length of one side of the cube with the following respective volumes. So here you're just taking the cube root of 512. And I think that's 8. And then the cube root of 7,000. So hard to give an exact answer here. And then the cube root of 45. So remember, you can go into the math menu and do this too. There's the cube root. All right. Box's dimensions LWH. If the dimensions are changed as indicated, get the volume of the new box. This is like a lot of what you did on worksheet 10.4b. So just the length is multiplied by 4. So our original volume is LWH. If we multiply the length by 4, then we're going to end up with 4 times the volume. So give the volume of the new box for LWH. Its length multiplied by 3, its width by 6, its height by 10. So 3L times 6W times 10H. And we're going to use a commutative property to put the numbers together. So 3 times 6 times 10 times LWH. And so that's 180. And then 5 is added to each dimension. This is the messy one, right? So I probably should have given more room. I'm going to actually use this room up here. So 5 is added to each dimension. L plus 5, W plus 5, H plus 5. And so multiply through the first two here. L times W, LW, L times 5, 5L, 5 times W, 5W, 5 times 5, 25. Now take that, multiply it by H plus 5. And so LWH plus 5LW plus 5LH plus 25L plus 5WH plus 25W plus 25H plus 125. So that's the volume. Need a bigger blank too. Okay, so here we have the volume of a flower tray. According to Governor Whitmer, I guess it's illegal to garden now, but moving on. Find the volume of the flower tray at the right. Its end pieces are shaped like isosceles trapezoids. So volume is the area of the base times the height. So a trapezoid, the area of a trapezoid is 1/2 the sum of the bases times the height. So this H here refers to the height of the prism. This H here refers to the height of the trapezoid. So let's put H trap here, H prism. Just so we don't confuse, they're not the same thing. All right, so let's start with the area of the base first. So 1/2. Now the tricky part here is we've got different units. So this part of the base here is 10 inches. This up here is 1 foot. So let's convert to inches, 12 inches. This is 2.5 feet. So we can convert that to inches too. That's 30 inches. So 1/2, 10 plus 12 times the height of the trapezoid is 8. And I got to multiply that whole piece by the height of the whole prism. Right, area of the base, this is area of the base, times the height of the whole prism, 30 inches. And this will give me my volume. So 1/2 of 22 is 11. So 11 times 8 is 88. 88 times 30 is 200, 300, and 3,040. Is that right? I blew that. Sorry. I mental math. I did 240 and then I added 64. I blew it. Sorry. 2640. I was trying to do 88 times 3 in my head. 240. Oh, I see what I did. Yeah, okay. I added 64 instead of 24. Sorry. So area of the base times the height gives you the volume. So this is in cubic inches. Now you could also do this in feet. If you did this all in, if you changed all the dimensions to feet, then you would end up with, we got to divide by 12 cubed, because there are 12 inches cubed in 1 cubic foot. And so if you did it in feet, you should have got 1.52 or 1.5, well, it says exact answer. So we wanted to figure out what that fraction is. Oops. (1936). So 1 and 1936 cubic feet. You probably did it in cubic inches, though, would be my guess. All right, how many gallons of oil can be stored in a cylindrical tank 8 feet long with a 5-foot diameter? 1 cubic foot is 7.5 gallons. That's in the textbook. You might remember doing a problem like that. So we got a cylindrical tank. So draw it this way. Here's my tank. And then okay, so here's my cylindrical tank. It's 8 feet long and has a 5-foot diameter. So first we got to figure out the volume of this thing. So the volume is the area of the base times the height. So the area of the base is pi 2.5 squared. Diameter is 5, radius is 2.5. And then times the height is 8. Okay, so that's 6.25 pi times 8. So that should be 50 pi. We'll just double check because my mental math has been sketchy. Okay, so 50 pi. But we should probably just find the decimal here. So 157 approximately. And that's cubic feet. Now every cubic foot holds 7.5 gallons. So we got to divide that by 7.5. And so we get, sorry, I did that the wrong way. Because we're looking at as 157 let me grab that number. Okay. We have 157 cubic feet, and every cubic foot holds 7.5 gallons. So we got to multiply by 7.5. Stupid thing. Okay. So we're looking at 1178.1, if we're round to the nearest hundredth, gallons. Of oil. Yeah, so if we wanted to do it exact, you do 50 times 7.5, and you'd get 375 pi gallons. All right, last question, number 10. Find the total weight of 30 steel rods shaped like regular hexagonal prisms with 3-inch sides and 20 feet long. The density of steel is 490 pounds per cubic foot. This was kind of like a extension problem. Did you want to really try your hand? So let's look at one steel rod. It's got a regular hexagonal prism is the shape of the rod. And I stink at this, but the idea here is, if your rod extends, right? And this is just going to look terrible, so be prepared for this. Man, this is worse than I thought it was going to be. Whatever. This side's looks kind of regular. I'm sorry, I don't draw well. You knew this. Okay, so this is 20, and it's got 3-inch sides. So this is 3, 3, 3, 3, 3, 3. And we got to figure out the volume of one rod. So, but this is in inches and this is in feet. So, but we're looking at 490 pounds per cubic foot. So we should really change these all to feet. So 3 inches is 1/4 of a foot. So we'll use that dimension. All right, so the key here, so looking at kind of your hexagonal base here. So this is 1/4. Let's look at this as 6 triangles. And because you can draw a circle in the middle, and there's 6 of them, 360 divided by 6 is 60. So these are all 60-degree angles. And what you're going to find is that because this is a regular hexagon, you're going to end up with each of these triangles here is an equilateral triangle when you split into 6 parts. So we got to find the area of this thing. So can we find the area of one of these triangles? Well, if it's equilateral, you could use Heron's formula, sorry, either way, and look at one triangle. Sorry, my drawing's small. So you got a equilateral triangle with 1/4 for each dimension. You can also drop the altitude here and do it that way. So then this piece here would be 1/8, and then this piece here, when you use the Pythagorean theorem, so 1/8 squared plus h squared equals 1/4 squared. You solve, you'll get 1/8 times the square root of 3. Right? So you can, fractions are tricky. Remember, 4/3 of all people don't understand fractions. So I'm saying if you solve this for h, you'll get 1/8 times the square root of 3. Okay, so the area of one triangle is 0.5 times 1/4, that's the length of the base, times the height, times 0.125, that's 1/8, times the square root of 3. And so that's the area of one triangle is 0.027 square feet. Now there's 6 of these triangles in my hexagon, so I got to multiply that by 6. So the area of my hexagonal base is 0.16 square feet. All right, so to find the volume of one rod, we need to take the area of the base, which we just found, and multiply it the height, which is 20. And so we end up with the volume of one rod is 3.25, this is approximate, cubic feet. All right, so now we got to figure out, we have 30 of these. So we can multiply by 30. And so the volume of 30 rods is about 97.43 cubic feet. And you probably remember from physical science that density is equal to mass over volume. So the density of steel is 490 pounds per cubic foot. And we're trying to find the total weight. So that's mass. So we know the density is 490 pounds per cubic foot. So for every 1 foot cubed. So this is stupid. Right, so we have 97.43 approximately cubic feet. Every cubic foot is 490 pounds. So if we take our volume, multiply it by 490, that's going to give us our mass. So our mass is going to equal 47,739.65 pounds. So maybe you got that, maybe you didn't. If you have any questions on this worksheet, feel free to email me and I can go over it in more detail, but hopefully that helps.